mathematics. So today we are taking one question, and this question is in front of you on the screen. Ho- Here is given that each of the resistance in the given network. These are the resistances shown in green. All of these resistances are of value R. Okay, you can see. So we need to find the equivalent resistance. We need to find the equivalent R between A and B, right? Between A and B, mind it. So where is A? Here it is A and here it's B. So to solve such questions, just do one thing. A and B is lying into the center of the network, center of the electrical circuit. Okay. So just pull this outside here. A to the left and B to the right. Like this. Pull it here. B to the right and A to the left. Then the circuit will look like this. Here we will be having A, right? And here we will be having B, right? And you can see from the branch of A, two R's are connected, these two R's, right? So this can be formed like this, right? So you can see one R here, one R here. Okay, these are these two R's, R and R. And apart from this, you can see from the end of these both R's, one single R is in short circuit, right? So you can say here this is the hi Nikhar, hello, good morning. So this is nothing but this R. You can see this R is just lying into the center. Okay, just pull this A to the left, then you can see from this line this R and these two R's are connected, which are into the center of the circuit, and through this one which is into the central as a short circuit. Now similarly, if you just pull B to the right, okay, here you can see two R's are connected from that branch like this, two R's. That means one R over here and one R over here, right? So students, you can see the above circuit will simplify like this. The above circuit will simplify like this, right? Tell me whether it happened or not. It will happen definitely. So have you seen this picture ever in your just courses, in your studies? This is nothing but just this is reflecting a Wheatstone bridge, right? So during the Wheatstone bridge, what we have learned, the ratio of the resistances which are connected to the left terminal, that means R1 by R2. If this was R1 and this was R2, then the ratio of R1 by R2 should be equal to the ratio of R3 by R4, where this is R3 and this was R4. If you remember the circuit, Wheatstone bridge, circuit of Wheatstone bridge, and here into the central line, just to see what volume of or what unit of current is flowing through the central line. Here a galvanometer was connected, right, which senses the flow of current through it, current or voltage. So there you can see in the Wheatstone bridge into the central branch, there will be no current flowing through it if the ratio of R1 by R2 and R3 by R4 are equal, right? So students, you can see here R1 by R2 is nothing but R by R, right? R by R, which is cancelled, and we have 1, right? Similarly, if this is R3, this is R4, the ratio of R3 by R4 is also nothing but R by R, because R3 is this one and R4 is this one, and here R and R will be cancelled and this will be 1. This was the condition for the Wheatstone bridge. When this condition have been followed, then in that case there will be no current flowing through this branch, no current, right? So if there will be no current flowing through the central branch, when into the Wheatstone bridge there was a galvanometer, if you recall, then the above circuit will be simplified and it will just look like this. A from here, and actually here it's B, and you can see two R's connected in, one from A, one R going on the top, this one, and one R into the bottom. These are these two R's which are coming over here. Then we have these two R's connected into the similar fashion from B. So this will be like this. And there was a central line through which a R was connected here. So this will not, right? Only these four R's will be existing into the circuit. We just resemble with this Wheatstone bridge where this criteria is satisfied. So that's why, since this criteria is satisfied, R1 by R2 equal to R3 by R4, then the above circuit can be written like this, can be redrawn like this. And now we have almost understood how to go ahead, because here you can see R and R are connected in series. So from here you can see R and R connected in series. That means here the equivalent resistance on the top, and here it's into the bottom. Okay, you can see here this R and this one, both are, you can see, connected in series and connected in series. So here it will be R plus R, and in the parallel line also it's R plus R. So both of these are coming as equal to 2R and 2R, right? Now the above circuit will be simplifying as A here it's 2R and 2R. So students, you can see here we have used the series formula in both the lines. Now this is the time to use the parallel one. because these two resistances of 2R and 2R are connected in parallel. So if you remember, for a parallel combination, the R equivalent, which is nothing but between the equivalent resistance between A and B, which is asked into the question, between A and B, will be equal to 1 by R1, which is equal to 2R, plus 1 by R2, which is again equal to 2R, this one. Now this will give you the value of R equivalent between A and B as this denominator is going into the numerator, so just it's a simple calculation. Here you can see 2R and into the, you can simple 2R is taken as LCM over here and 2R plus 2R, right? So simply 2R into 2R, just multiply it, and here again it's 1 plus 1. So you can only take only 2R because you are taking the LCM, so this will not be here. So simply you can see 2 and 2 will be cancelled out and only R will be left. These 2 and these 2 will be cancelled out and we have only R as the equivalent resistance between AB. So in this way, here it's simple, the parallel combination, the equivalent resistance will be 1 by 2R plus 1 by 2R, which is equal to 2R, which is taken as LCM of both, divided by 1 plus 1. So these two will be cancelling these two and we have R with us. So students, we have solved our question, and we can say here into this question the equivalent resistance R between A and B is nothing but it's equal to R, and this is our answer. So in this way students, we have solved our question. Thank you so much for watching. Take care and happy learning. Hi Nikar. Hey bro. Yes, I told your name as you said. Any query over here? Let me know. So this is the entire solution in front of you. This is the entire solution in front of you. You can see this was the circuit given to you. You have to find the equivalent resistance between A and B, where A and B are these 2 points, A and B. And here R, 5 resistances we are connected into the different branches of this circuit. So the above circuit can be simplified as this: when A will be pulled to the left, when this A is pulled to left and B is pulled to right, when you just do this, the circuit will be forming like this, where this R and R, which is directly connected through the branch of A, will be the resistances into the left branches connected directly with A. Similarly, these two R's will be connected through B, so this will be here, right? So if you remember the Wheatstone bridge, right, and these are the simple, this is coming into the central branch, these are. So here you can see, if you remember, the Wheatstone bridge and a galvanometer was connected through the central branch, through the short circuited branch. What was happening? the ratio of R1 by R2 should be equal to R3 by R4. If this condition have been followed, which is happening over here, because if you put up the value of R1 and R2 and R3 and R4, you get the value ratio of we get the value of ratio R1 by R2 as 1 and R3 by R4 is also equal to 1, because all the resistances are of R, are of value R. So since 1 is equal to 1, we can say that this Wheatstone bridge condition have been followed. In this condition, there will be no current flowing through the central branch, where if you recall there was a galvanometer connected. So since there will be no current through the central branch, so the above circuit can be simplified at like this, and the central R will be removed. Now, after this, you can see this R and R is just simply connected in series, whose equivalent resistance is nothing but equal to R plus R equal to 2R. Similarly, this bottom line into the second line, 2R are these are also connected in series, whose equivalent resistance is nothing but R plus R equal to 2R. So this circuit can be further simplified as like this. 2R and 2R, these two resistances are connected in parallel. So the equivalent resistance between these two terminals A and B, the value of equivalent resistance is nothing but the equivalent resistance of these two parallel connected circuits having a resistance of 2R and 2R. Here you can see this one. So R equivalent is 1 by 2R plus 1 by 2R. When 2R is taken as LCM, so here what we did is simply put R equivalent is equal to 2R by this 1 plus 1, 2, and 2 and 2 will be cancelled out, and we have the value R as equivalent resistance. So that is the same thing which I have written over here, this R. So that's why our answer is nothing but R. So the equivalent resistance between A and B is equal to R, right? I hope it's visible to you. So that's why I zoomed it in early phase. This was the question in front of you, and this have been gradually, these are the steps which have been followed. The above circuit will be simplified as like this. Understanding the concept of Wheatstone bridge, we can see there will be no current passing through the central branch, and the above circuit can be simplified as like this, because the ratio of this R1, R2, R3, R4, which is nothing but all these R1, R2, R3, R4, these 4 R's, and the ratio of these 4 R's, you can see R by R is nothing but 1, and also R3 by R4, let's put up the value, it's also nothing but 1. So here you can see this condition is followed, that means R1 by R2 is equal to R3 by R4. So this criteria of Wheatstone bridge is followed. Since this criteria is followed, which criteria? Criteria of this Wheatstone bridge. Then if this condition is followed, then we can say that through this central branch, through this R, there will be no current flowing through it. That's why I crossed it. So the above circuit will be simplified at like this, having no central branch. Which central branch? This is the same resistance which was there into the left and here into the central. So this R will not be the, there will no current will be flowing through it. So that's why we can omit this R. We can omit this R, right? So our circuit will be looking like this. You can see two resistances connected in series into a branch parallel with another branch having two resistances connected in series. So the above circuit will be simplified as R plus R into the top, and into the bottom it's again R plus R, because you can see these are series connected in both the branches. Two are connected in series into the top branch, which will give you the equivalent resistance as R plus R equal to 2R. Similarly, it happened into the bottom branch, which is also equal to 2R. Now the above circuit will be simplified as, you can see, 2R connected with 2R in parallel. What will be the equivalent resistance? 1 by R equivalent, that is between this A and this B, is equal to 1 by 2R, this one, divided by 1 by 2R. So this will be giving you 2R is taken as LCM. Here you can see 2R is taken as LCM, and here 1 plus 1 2. So 2 will be cancelled, and we have R. So this R, here I have again written it earlier over here. This R is the equivalent resistance. Equivalent resistance of, let us go to the question, equivalent resistance between the two terminals A and B, right? So this is our answer, students, and in this way we have solved this question. Thank you so much for watching. Just stay connected, take care, happy learning, bye bye, see you guys.